Okay, so today we're going to be talking about infrastructure as code, and particularly Terraform, and how that fits into the overall development process. So my name is Brian Minisi. I'm a solution architect with Nudesic. I'm also a Microsoft MVP and one of the organizers of the Tech Bash conference. And Andy's on right now, so he's also one of the organizers of Tech Bash. I don't have a slide for it, so I don't know if Andy wants to introduce Tech Bash or not. If not, I'm just going to continue. But we are having our conference coming up in the fall. The exact dates I'm not sure of at the moment, but keep an eye out for that. All right, so let's get started with what infrastructure as code is and what that means. So the whole idea with development is that we want to have a repeatable process and reliability in deploying code over and over again, so that we know the steps that it's going to be going through and that we are guaranteed that the same steps are going to happen from environment to environment. So we want to take that same approach and apply that to operations, the people that are involved with creating the infrastructure in the cloud. So what infrastructure as code gives us the ability to do is to write scripts that will create our infrastructure, and we can have that be repeatable from environment to environment. So Azure Resource Manager provides these capabilities for Azure out of the box using ARM templates. And that also works not just across Azure, but also Azure Stack. But we also have third-party tools that can do this too, such as Terraform, Ansible, Chef, Puppet, and so on. So if you're going to be using a third-party tool like Terraform, it gives you those capabilities that you can do with ARM templates. So when we're talking about having the development process the same for developers as with operations, we're basically talking about going through the whole process of we're writing our code, we're planning what will happen with it, how it's going to get deployed, and then we deploy it, and then we make changes, and we go through the same process over and over again. So it's the same type of idea for developers as it is for operations. So they're going through the same type of, they're basically parallel to each other. So they're going through the same process. So with Terraform, we have this ability to map out what our infrastructure is going to look like, and we're able to do it in a way that's pretty readable. Terraform uses HCL, which is the HashiCorp configuration language. It's a YAML type of syntax, and I'll go through what all of this means when we go through the demo. But basically, you can see here that this is creating a virtual network, the first one, and the second one is creating a subnet within that same virtual network. Not a whole lot of lines of code here. If you go look at an ARM template, you would see that there's a whole lot more that has to be done in an ARM template to do the same exact thing. So Terraform basically abstracts that complexity away from you and makes it more approachable for people to jump into infrastructure as code. So Terraform has some file types that are very important for creating these infrastructure as code files. So we have a tf-vars file, and that's where we're going to be we would put our variables. We have a provider file. We have a Terraform instance file, which is a .tf file. That's the file that we're going to be putting all of our definitions for the infrastructure in. And we also have a state file. The state file is very important because the difference between Terraform and ARM is ARM will go and look at the actual resources that have been created already in Azure. So we'll go look at Azure directly and see what was created before it creates its execution plan. However, with Terraform, it doesn't do that. It creates a state file, and that state file has the definition of what's been created in Azure. So it doesn't actually go and look at Azure when you run a Terraform script. It looks at its state file. So there's good parts of that and bad parts of that. Good part is it's faster than ARM because it's a file that it's looking at, rather than going to Azure and trying to figure out what's been created already. But the problem also is that state file can become corrupted. So if it becomes corrupted, then the Terraform, or if you lose the state file, Terraform will break. It will throw errors because it will try to create resources that have already been created. And in some instances, such as web apps, which have globally unique names, that will fail because it will try to create the same thing again, but it's already been taken up with an app service that's there already. So there are a bunch of commands that we can use with Terraform, but there are, out of all these commands, there are really only a few that you would use on a regular basis. So for example, we would use a Terraform init to get the working directory set up with the Terraform provider and the resource that we need in order to run Terraform for the specific cloud platform that we're running. We have a plan command, and what this will do is this will not actually create the resources for you, but will create the execution plan. What it will do when you do run this. So it gives you the ability to actually go in and look at what the execution plan is and check it out and do a review of it before you actually run it. And then you have the apply command. And what the apply command will do is actually apply the configuration that you've created within the Terraform script. So this was actually the command that will execute the script and create the resources for you. And then there's an import command. And what the import command does is if your state file becomes corrupt, for example, we can rebuild it by using the import command. So this will allow you to do a command for every single resource that's been created in Azure that you want to create. And it will recreate the state file for you. But it's individual commands that you would have to run. So let's get into what this actually looks like in real life. All right, let me get situated here. All right, so you can see here we have 3 files that represent what we're trying to do. This webapp.tf one, this could be any name you want, of course, but it has to have the .tf extension. This is the definition of what we're trying to create. So these are the instructions for creating the resources that we want. There's a variable.tf file, and this allows us to create variables and set default values for them. However, we may not want to have default values in here. So we have this tfvars file, and this is the file that we can use to put the actual values in per environment that we want to deploy to. So you could have a tfvars file for the dev environment, one for the test environment, all having the different variable values that you would need for those different environments. And now going back to the webapp.tf, let's see what this is doing. So the first thing that we have here is we have to specify the provider. And the provider here is Azure, so we put in here. The next sections are the actual resources that we want to create. So in HCL language, it's set up that you would have a resource. You would have the type of resource. So this is a resource group. This is telling to create a resource group. And then this is the name of this whole section here in case it needs to be used later on. So you can reference this plus this in order to get the values that you might want to use in subsequent steps within your Terraform script. So that's for the resource group. So we pass in the name, we pass in the location. And what this will do, this will create the resource group for you, just this whole section right here. And you can see we're using a variable. So this var.resource group name is what we have here. So we will pull in that value. So the next part of this is creating the app service. So you can see here we have an app service plan that we want to create. We're naming this dev, and then we have other properties such as name, location. Here is where we are specifying the resource group that is going to create the plan in, and we are referencing what is going on here, what we did here, by using this name .dev, and then we can get the name of the resource group. And of course, we have other properties such as the SKU that we need. So that's for the plan. And I just want to also point out here with the name, we are using a variable, and then we're using the suffix variable. And when we go back here to the variable file, you see we have the ability to create variables that are basically an object. So we are able to use one variable and then specify what we want to pull from that, either plan or web or whatever else you have in here. So if we come here, we can see we have var.suffixes, and then we're saying to use the plan variable, which is basically just going to be -plan as the value. And we join it and concatenate it by using the join command here. So here we have the app service. So this is a type of resource plus the name that we're going to use. So we have the same thing. We have name, location, the resource group name, which is referencing this again, and the app service plan ID. So we can see here that this is referencing this section and this name, and then we're getting the ID. And then the next section we have are if you want to create other things in here. This is very simple what we're doing here, but you can get very complex as far as configuring the app service. In this case, we're just we're going to create the configuration as far as the app settings are concerned. And we can put in here whatever app settings we want to have created when we're creating the app service. Okay, so this is it's a very simple file definition, but if we go look at what the same type of definition when we're using ARM, this is what the ARM equivalent would look like. So we have parameters here, which is very wordy. And then getting down into the resources section, this is what it takes to write in order to create the exact same thing in an ARM template versus Terraform. Now, ARM gives us greater capabilities in order to create our resources and configure them, but it's a much steeper learning curve to learn ARM versus Terraform. So that's the real value add of Terraform, is it's more approachable and it allows people to get into IAC without such a steep learning curve. All right, so getting back to here.
Brian.
Yes.
What are some of the things that you said it's more flexible? What can you do in ARM that you can't do in Terraform?
So that depends. When there are some gaps in Terraform, but Microsoft is trying to close those gaps, there are some configurations and resource types that you cannot do in Terraform that you can do in ARM, and it's just because Terraform hasn't created them yet. So Microsoft is working on that in order to close those gaps to make it in parity with ARM templates. So it doesn't really do it. You won't really see it if you're doing basic stuff, but when you're getting into very, very deep type of configuration with IAC, you could run into those type of limitations in Terraform. You know, for example, I was on a project where I came into the project and they were using Terraform, and there's a lot of stuff that they couldn't do. So I had to, we all decided we have to convert it over to ARM templates. So we rewrote them in ARM templates because Terraform had too many limitations for doing what they needed to do. But hopefully that over time will go away and you won't have those type of disparities between the two. Any other questions?
Yeah, just a general comment. It's always like Terraform's always going to catch up to any new features that Microsoft and Amazon has. So just keep that in mind when you're deciding
Exactly.
which one to use.
Exactly. And like I said, those limitations, it gets pretty low level when you
Yeah,
hit limitations.
it's usually edge cases.
It is edge cases, definitely. So definitely, if you like Terraform, keep using it. Those limitations are going to go away if you ever hit them.
Now, my question, Brian, is that is it always an either or have you seen implementation where it's a hybrid?
You definitely can have hybrid. You can actually even call ARM templates from Terraform scripts. So that capability exists. And you definitely can have a combination of Terraform and ARM templates. That project that I was talking about, that's what they did. We slowly converted everything over to ARM, but that wasn't going to happen overnight.
Mm-hmm.
So they had to use both for a time period until they did do the full conversion.
Gotcha. Thanks.
All right. So how do we do this? How do we actually run this and make it create the resources that we create? So the first thing we need to do is we have to initialize our working directory here. So the way you do that is by running the command terraform init. And what this will do is this will bring down, it will look at this script, and it will see that we want to use Azure. So it will then go and initialize the working directory with the Azure provider. And we'll see it over here once it gets created. Okay, so it's been initialized. So what did this create? So this created this .terraform folder. And within here, you see we have this is an exe file, but it's the Azure provider. So if you're going against other platforms like AWS, it would see that the provider is AWS, and then it would add the AWS provider here. So that's what the init does. It allows us to run our commands. So you have to do the init first before you can run anything. Okay, so what would we do next? So the next thing we would want to do is create a plan. So we want to see what this is going to do, what it's going to create in Azure before we actually run it. So the way we would do that is running the plan command. So it's terraform plan. And here we want to specify our var file right here, because this has the values that we need. So we do -var file. Specify the name of the file, stack vars.tf vars. And the last thing that we want to do is output this plan, because when we go and review this, when we do the apply, in order to create the resources, we want to make sure we use that plan that we already reviewed. Because if we don't specify the plan, what it's going to do is when we do the apply, it's just going to go and do the plan behind the scenes and then run it without you being able to review. So you really don't know what it's going to do. So the way we do this is we output the plan. So basically the plan is, the name of the plan is, has a TF plan extension to it. All right, so let's run this. Of course, it takes a little bit of time, but it is faster than ARM templates. I have a feeling that Teams is slowing this up even more. All right, so it did the plan. And what it's saying is it's going to add 3 resources to that resource group because we don't even have the resource group created yet. So it's going to create the resource group, create the app service plan, and then create the app service. So it's saying it's not going to change anything and it's not going to destroy anything. And you can go up here and look at everything that it's going to do. So these plus signs here are saying that these are adds. And it's a bit more complex than what we really need. So we see here we have the name for the web with that concatenation of the suffixes variable. And keep going down here. You can see all the stuff that it does behind the scenes. We have the plan here with the suffixes -plan. All right, so everything looks good. So when we go to apply this, we want to also specify the plan. So over here, you see we have our plan file, and this is a binary file. So it's not something you can really look at. So let's do the apply. And all we have to do here is specify what plan. Now, while this is running, you'll see over here that a state file will be created. Okay, so there's our state file. So now it's going and creating the resources. So it created the resource group. It's creating the app service plan. And then the last thing it will do is create the app service. So it completed, and it said it added 3 resources, changed and destroyed no resources. So let's go and take a look at our resource group. And here it is. So if we go look at the web, some of the things that we specified for the configuration for the app settings. And you can see here, we have them here. So it did that successfully. So the next thing I want to show you is, let's say we make a change to our definition here, to our configuration. So let's say we want to add another app setting. So we can say philly.net equals cool. So we want to have it to be a string, of course. All right, so we changed the definition. So we want to run our plan again because we want to figure out what the new definition is going to be before we run it, the execution plan. However, the plan that we currently have is a plan for creating new resources that don't exist yet. So if we use the existing plan, it's going to fail and it's going to corrupt our state file. So, this is what our state file looks like. It has the very in-depth stuff that we need for creating the resources, stuff that we don't have, we do not want to write ourselves. So if this becomes corrupted, we're going to have to run commands for every single resource in order to import and rebuild the state file. So we don't want to do that. So how do we recreate this plan file? So I'm going to do a plan again. And am I retyping? All right, so we have a plan here. We want to output our plan, but we want to also tell it to refresh the plan. If we don't do that, it's going to use the existing one. And it's going to fail for the reasons that I mentioned. The refresh is going to say, hey, let's go recreate the plan. In this case, it's going to look at this state file that exists and recreate the plan based on the state file. It's not going to go to Azure to do this. It's going to go look at the state file, keeping everything local. Thus, it's quicker, it's faster. So how do you get Terraform on your machine? Terraform is basically, you download it, it's an exe, it doesn't install. It's an exe, you have to put that exe in a folder somewhere on your machine and then add it into the environment variables and the path, that path to that Terraform file, and that will allow us to do these types of commands here. So if everything works okay, it's not going to add anything like it's saying here. It's going to change one thing, and it's going to destroy nothing. So we can go back and look and see everything that it's going to do. So we can see here's the change. We're just adding this one thing. And it's not going to touch anything else. All right, so when we run the apply, we're still going to specify the plan because the plan has been updated. So let's run that. And by the way, tomorrow at 11, I'm presenting a similar IAC talk, but it's on Project Bicep. And Project Bicep is something that Microsoft's creating a domain-specific language for ARM templates. So it's a YAML type of syntax, but it abstracts all of that complexity that you see in an ARM template, basically making it as approachable as Terraform is. It's brand new, it's not released yet, it's still in development. So it's not for production use. But if you're interested in seeing that, I'll be talking about that at 11 tomorrow. All right, so it looks like it completed. Had one change, so let's go take a look and see if that actually happened. And so it added a new app setting. All right, so that worked. So any questions about this? This is what we just did right here was run this locally, which is great, but in the real world, that's not what we would be doing. We would be doing this in a pipeline. Now, there's some issues with the state file in a pipeline. And the reason is, unless you have a agent machine that's going to be there all the time, an on-premises agent machine, if you're going to use a cloud-hosted agent machine in order to do your build and your deploys, that state file isn't going to be there. So how do you do it then? So let's go take a look at how we would do that. All right, so let's go over here. So this is our same file, but it's now configured to use a back-end place to store our state file in Azure, so that when we run this in a pipeline, it will always go and look at that state file that's stored in a storage account. So we see here, we have this section that's been added. So this back-end configuration is how we're doing it. So we have the storage account name, and this is going to be a token. So we're tokenizing this, and we're going to replace these tokens within the pipeline, because in this case, we're going to be using the same pipeline in order to deploy to dev, to test, to UAT, and to prod. So these variables have to change, of course. We can't use the same names for the resources for like a web app in the different environments. So what this is going to do is we're going to replace these tokens here. And these tokens are specified using these prefix and the suffix type of indicator. So we have the storage account name that will be replaced. We have the container name, and we have the name of the state file. And we're also going to need the storage account key. But everything else here is exactly the same. So let's go take a look at that. All right, so if we go look at the storage account. We have a storage account here. And within that storage account, we have a container. And within that container, we don't have a state file yet because we haven't run it. Now, let's go to our pipelines and take a look. So within our pipelines, we have a build. I'm using the classic UI here. Tomorrow, I'll be using YAML for the bicep one. But we're not only creating infrastructure within this pipeline, but we're also going to deploy the application. So that's why we have the .NET Core steps here. We're going to copy the Terraform scripts because it's in our repos. Right here. And then once we do the build, we're going to release it. So within our release, we're going to use the build artifact that was created. And then here, we're going to go through a series of steps in order to deploy our infrastructure and our application. So the first thing it's going to do is create the storage account if it's not created already. So this is idempotent with the AZ. So if it's created already, it won't fail. It will just see that it's been created. So it's going to create the storage account, it's going to create the container, and then it's going to list out the storage account keys. And over here, we're going to get the key, and we're going to set it to a variable. So we have a series of variables here that we're going to be using. So we have app service name. We have app service plan. We have a resource group, which is going to be different than the one we just created. And then we have the storage account key, which is going to get populated when we run this, as you saw in that last step that we looked at. And then the name of the storage account and the container. So those are the things that we have in our variables. So that's what this is going to do. It's going to take the key and assign it to our variable that we had here. And this is going to allow us to use this later on. So the next thing we're going to do is replace those tokens that I showed you within the within here, these things. So basically, it's a replace token task. And we're going to tell it to look for these prefixes and suffixes in order to replace those tokens with the values that are in the variable. So the variable name has to match the name that's in here in order to have this work. All right, so after that's done, we're going to install or init or install Terraform. This is the most recent version. The step after that is going to be the init that we just saw. But the big difference here is we have this back-end configuration that we can tell it to use. So we're telling it to use our Azure subscription. We're telling it the resource group for the storage account where we're going to be putting the state file in, the resource group, and then the storage account, the container name, and this is going to be the name of the state file. So you need it here, and you also need that back-end configuration within the Terraform script itself. So here we have a plan. However, the plan here really isn't going to do much for us because this is running on a cloud-hosted machine. We don't have access to it. So we can't actually go and look at the plan to see if it's going to be something that is going to work or not. However, the plan could at least try to compile what we're trying to do, and if there's a syntax error, it will fail. But we really don't know what it's going to do. So this is just going to check to see if there are any syntax errors in order to prevent this from being applied. So the next thing we'll do is the apply. And after the apply is done, we have created our infrastructure. We're going to deploy our web app tool. Any questions about that before I launch this? All right, so let me kick this off. So this is running on a cloud-hosted machine, so it's downloading the artifacts from the build. We did the build previously, so we didn't have to run it this time. So now it's checking to make sure that the storage account is there. And as we saw over here, we already had the storage account created. So it's not going to do anything else. It's just going to check.
Can you hear me now?
Yes.
A quick question on the on the release steps. Are those Terraform steps and the replace token, are those standard in the pipelines, or is it something you have to get from the store?
Well, the Terraform and the replace tokens are things you have to get from the marketplace.
Okay.
So they're not actually built in, but they're in the marketplace.
Okay, thanks.
Okay, so now it's installing Terraform on the hosted agent. Cloud hosted, did the init with the backend configuration. So now it's going through the plan. And now it's doing the apply. But the plan, we can go and actually look at it here when it's running. So theoretically, you could put a manual step in there, a manual override step in order to look at the plan before you continue. But that's not something you really want to do. So you don't want any bottlenecks. We are talking about DevOps. We want to remove all bottlenecks and things that will slow things down. All right, so it looks like the apply worked. It added 3 resources. And then the next thing it's going to do is now just deploy the code to the app service.
So before, when you change something, you had to go and change the plan command to do a put, right? So is that how it would work here through the pipeline as well?
No, because we're not actually referencing the plan in this case.
Okay.
We could, but the whole purpose of a plan is that we can review it ahead of time. If we can't do that, then there's really no reason to output it. I mean, the apply is going to do the same thing that a plan does, except then apply what the plan comes out, the execution plan.
Okay, thanks.
I'm just using this as a compile type of thing. Like if you have a syntax error, it will fail the pipeline. All right, so it completed. So let's go take a look. So this is the storage account. So let's see if that state file was created, and it was. So we have our state file here. So what this means is every time we run this pipeline, it's going to use this state file. Otherwise, it's going to fail. And I'll show you what that looks like too. So this is our state file that we saw before. Like I said, very complex. So now if we come back here and look at our pipeline resource group, you see we have everything created here. So it's just created. And if we browse, we should see our app running. When it wants to come on. And there we go. So this was the end-to-end pipeline for creating our infrastructure and then deploying our code. So when we're doing pipelines, we want to actually have that infrastructure as part of our development process. So having it part of a pipeline means that we're guaranteeing that the infrastructure is going to be there and it's going to be configured the way we want to. Of course, a lot of operations and cloud services teams, they want to have control in creating the infrastructure. So it may not be part of a pipeline that deploys the code. It depends on the organization that you're working at, whether they want to keep it as part of the code pipeline or separate it out. Either way, you're still creating the infrastructure using code. So you know what it's going to do, and you know it's going to do the same thing over and over again every time you want to deploy that type of infrastructure. So if we come back here, I just want to show you in the last 5 minutes what will happen if we don't have the state file. So let's delete the state file. So it's now gone. And let's go over here and kick this off again. So whether it fails or not without the state file really depends on the type of resource that it's creating. If it's a resource like a resource group, it won't fail because it's not a globally unique thing. For some reason, some resources, it's idempotent, and other resources, it's not. The ones that it's not idempotent are the ones that have globally unique names to them, such as web apps. So if it tries to create the web app again, it's going to say, hey, wait a minute, this has to be unique. It's already there. So I'm going to fail. But for resource groups, it won't. So when this goes and creates our state file, it's not going to see that since it doesn't have a state file, it's going to think that it needs to create all the resources again from scratch. And that's where we're going to run into the problem. Because Terraform just looks at the state file. It doesn't go and look at Azure to figure out what's there, as ARM templates do. So as I mentioned, the state file is great as far as speed, but it could, if it becomes corrupt, it could cause problems because you have three things you can do in order to correct it. Delete all your resources from Azure and then start over again, which you can't do in a prod environment, of course, or practically any environment. The other thing is you can write the state file by hand, which is, unless you're a genius of state files, I don't recommend doing that because it's very complex. Or you can use the import command. So if you do have a Terraform script, it'd probably be a good idea to write an import script that you could run that represents every single resource in case the state file gets corrupted. So you could just recreate it again and then upload it to the storage account. So you can see here it's going to say so here at the end it's saying it wants to add the resources again, which we don't want to have happen because the resources are already there. So it will fail on the apply. And if we go look at this, we can take a look at the error message here. And where is that? So it doesn't really give you much information here as far as what the error is. So it says error, it says already exists. So it actually failed on the resource group, which is new because it doesn't always do that. Or at least it didn't do that before. So it's kind of weird what is idempotent and what's not idempotent within Terraform.
Hey, Brian, question.
Yeah.
When you run import, does that go against your existing, I guess, infrastructure environment?
No, it doesn't. So when you do the import, it's going to go against your file here, and it's going to go look at the state file. But what it will do is it will just import these resources again.
Oh, okay. Is there a way to tell Terraform to look at what's out there and give me a state file?
Yeah, when you do an import command, you have to specify the resource. So I guess it does in a certain extent. Let me show you what this looks like.
Yeah, because it's for those that have been burned with a corrupted state file. It's not fun.
Right, exactly. So let's see. Let me this. All right, so we can see here that this import command, you have to tell it what resource you want to import, which in this case is the app service up here. So you say what the resource type is and then the name that you gave to it. And then you have to specify the resource ID that's in Azure right here. I'm sorry, this got pretty screwed up. Get rid of this. So we have the resource ID. So in this case, I think it does go and look at it will go, since you specify the resource ID, it will go look at Azure in the import command. So I correct myself there. But that's unique to the import command. So what we'll do is it will add this resource based on what's been created in Azure already to the state file. But then when you run the plan and the apply, it won't go and look at the Azure resources in Azure, it will only look at the state file.
Yeah, so basically you're reintroducing that resource back into Terraform.
Right, back to the state file.
You're telling Terraform, hey, I actually have this resource.
Right, exactly. And you have to get this resource ID, but you can use AZ commands to do that. All right, any other questions? I think we're at the end of our hour. So I'd like to thank everybody from joining. And like I said, I'm going to be giving a bicep talk tomorrow. It'll be the first time I've made it because this is brand new, this project bicep. So that should be interesting. But if you're interested in seeing how we can introduce a Terraform type of approach to ARM templates, that's what Project Bicep is.
All right, well, thank you, Brian, and we'll look forward to tomorrow's session then.
Sounds great.
Thank you.
Thank you very much.